This is Pete Johnson from Sifos Technologies. During the next few minutes, I plan to review the full range of Sifos products and solutions. Sifos Technologies has developed a reputation for innovation and leadership in two technologies that generally relate to Ethernet physical layer interfaces: Power over Ethernet test and Ethernet twisted pair physical layer test. Let me start with a brief background of Sifos Technologies. We are a relatively young technology company founded in 2003 and located just north of Boston, Massachusetts. Sifos is a self-funded corporation that is almost entirely employee-owned and operated. Sifos personnel combine over 75 years of test and measurement experience, formerly with Hewlett-Packard and Agilent Technologies. This includes over 60 man-years of developing test solutions for the communications equipment marketplace. Sifos Technologies is represented by various independent distributors and manufacturers representatives around the world. Each of these organizations has exclusive rights to sell and support Sifos solutions within their respective geographies. Sifos works very carefully to select and support these businesses so that they can provide the maximum possible value to all of our customers. As a technology and marketplace, Power over Ethernet has evolved considerably during the last decade. First, let's consider the proliferation of PoE. Many large manufacturers of Ethernet switches now offer PoE as a standard feature or option to their full range of edge access products. Powered devices have diversified from traditional IP phones and wireless access points into many new applications, including security cameras, professional audio components, point-of-sale terminals, card readers, and even test instrumentation. The present interoperability standard for PoE is IEEE 802.3 AT, allowing powered devices that consume up to 25.5 watts. IEEE is working on a new replacement standard, 802.3 BT, that will eventually enable power loads approaching 90 watts, thus enabling exciting advances in future smart lighting systems as well as power to televisions, displays, microcell base stations, high-power wireless access points, and computers. This standard will also promote higher efficiency powering of all devices. The traditional concept of product interop testing is no longer viable. The wide latitude afforded to PoE product developers by the 802.3 AT specification has resulted in a wide variety of methods by which PSEs identify and characterize PDs, and in the ways that PSEs manage power and assure safety in that power delivery. There are currently many dozens of silicon-level components available on the market today for implementing PoE and PSEs and PDs. With the upcoming 802.3 BT standard, the range of implementation options will explode relative to what it is today. The notion that the PoE silicon alone dictates compliance or non-compliance to IEEE specification is simply not accurate. Most PSE silicon available today is highly programmable and configurable such that specification compliance is as much dependent on device programming as it is on the actual silicon itself. On the PD side, various critical compliance parameters are determined by PD design factors separate from the PoE silicon component. The 802.3 AT standard introduced a new link layer packet protocol to facilitate efficient and accurate power management in larger multi-port PSEs. This variant of LLDP deviates from the tradition of LLDP in that it is a handshaking and timed protocol dialogue that occurs between PSEs and PDs following the application of power. All Type 2 PDs, as well as future Type 3 and Type 4 PDs, that is, PDs requiring greater than 13 watts, are required to support this Ethernet MAC layer protocol. This adds a whole new challenge to both PSE and PD developers. Finally, the management of power in a multi-port PSE such as a 48-port Ethernet switch is an increasingly complicated challenge. Fixed total power budgets must be sliced more accurately over a wider per-port power range between 1 and 30 watts at the PSE. Picture the complexity of a power management task given a 48-port Ethernet switch with a 750-watt battery-backed power supply distributing up to 30 watts per port to a wide diversity of powered devices. Modern PSEs all face these challenges. Power over Ethernet testing solutions from Sifos Technologies can be arranged on both product lifecycle and test process dimensions. For many equipment manufacturers, product lifecycle would include steps of component evaluation, design verification, and manufacture. Test processes typically include specification compliance analysis, system and software testing, and final functional test. Sifos offers products that span both of these dimensions. The PowerSync Analyzer family addresses PSE test needs ranging from rigorous IEEE 802.3 compliance testing to high volume, high coverage, and low per port cost functional testing. The PSA 3000 platform occupies a center point in this distribution and, depending on configuration, can cover any of the application areas shown. The PSA 3000 may be configured with the de facto industry standard PSE Conformance test suite for fully automated PSE specification compliance testing, with LLDP analysis for PoE LLDP protocol emulation and testing, and with the PSE Multiport suite for PSE system and power management analysis. It is also configurable from 2 to 24 ports. The PSA 3002 Compact PSA also supports the PSE Conformance test suite as well as LLDP analysis, and is a good fit for low-volume design evaluation as well as any portable applications. The RackPack PSA 3048 offers 48 PSE 3000 test ports at a discounted price per port and can be configured with the PSE Multiport suite, LLDP analysis, and/or the PSE Conformance test suite. To system software developers, the PSA 3048 with the Multiport test suite and LLDP analysis can be configured to fully emulate 48 copies of virtually any powered device imaginable, while also supporting a fully automated 48-port system test of PSE power administration and power management behaviors. For automated high-volume QA and manufacturing, Sifos provides prefabricated scripts called PSA Quick Test and PSL Quick Test. These software modules may be used as is or with user modifications to test multi-port PSEs, generating between 8 and 12 critical test parameters per PSE port at a rate of 8 to 20 seconds per port tested. The PDA 602A is Sifos' third-generation PD analyzer, offering highly automated 802.3 AT powered device conformance testing and PD loading analysis. The PDA 602A is a feature-scalable instrument that can be optimized for design verification, manufacturing test, and/or field service applications. That means that, like the PowerSync Analyzer family, end users pay only for the features they need. Those may include Type 2 PD testing, automated PD conformance test suite and load monitor, and/or PD LLDP protocol analysis and flexible PSE LLDP emulation. Feature updates can be procured and installed with license keys. The PDA 602A also provides a flexible and powerful programming environment that is geared for automated testing. Future PD analyzers aimed at the emerging 802.3bt standard will be extensions of the PDA 600 family. Let's first summarize the critical features of the PowerSync Analyzer family of products. First, the PSA 3000 is the most comprehensive, versatile, and automated IEEE 802.3 AT PSE conformance tester on the market by far. It is the de facto industry standard used by most of the PSE silicon vendors. The PSA 3000 is the only PSE tester that fully eliminates the need for all other test equipment and test support apparatus in the development and QA of PoE switches. It even includes emulation and protocol analysis for the PoE LLDP protocols. The PowerSync Analyzer family offers the only commercial solution for fully automated and highly innovative system power management testing of 802.3 AT PSEs up to 192 powered ports. The PowerSync Analyzer family of PoE test solutions is highly scalable with low entry points, flexible configurations, and field upgrade capability for features such as PSE Conformance Test, PSE Multiport Suite, and LLDP emulation and analysis. Finally, the PowerSync Analyzer family is the only commercial-grade test equipment available for PSE test, robustly documented and compliance tested, including CSA safety certification, CE mark, and FCC compliance verification. Every instrument will operate with continuous loading of over 42 watts on every test port, providing conservative headroom for PSE test requirements. The PSA 3000 PowerSync analyzer offers accurate static DC power loading in excess of 42 watts continuously per test port. Static load characteristics are further complemented by a flexibly triggered and programmed transient load capability, including optional foldback suppression critical to measurements of PSE inrush response and short circuit response. Transient loads can be programmed up to 1.8 amps with multi-step durations starting at 200 microseconds. The PowerSync analyzer uses efficient fans that operate only as needed in response to power loading. The PowerSync analyzer offers highly flexible metering for DC port voltage, DC load current, DC power, AC noise, and time interval. DC metering offers programmable time apertures for average, min-max, peak, and scope trace voltages and load currents. Versatile triggering features include waveform and event triggers may be applied to all DC voltage and current meters, to transient loads, and to LLDP protocol sequencing. One-button waveform analysis enables rapid acquisition, analysis, and troubleshooting of PSE behaviors given user-defined PD emulations. Standard waveforms are automatically captured and displayed for various detection, classification, power-up, overload, dynamic load, and shutdown test conditions. Captured waveforms are easily exported to Microsoft Excel for detailed analysis. The PSA 3000 is packaged in one of three configurations: a chassis accommodating up to 12 test blades with 2 test ports per test blade, a compact PSA 3002 with 2 test ports, and a rack pack PSA consisting of 2 chassis and 48 test ports. The rack pack offers the lowest per port cost for PSA 3000 test ports. PowerSync analyzers offer 3 powerful options for highly automated one-button PSE testing and analysis. The PSE Conformance Test Suite provides comprehensive and fully automated analyses of PSE specification compliance. The PSE Multiport Suite offers comprehensive analysis of PSE power management and administrative behaviors under a wide variety of PD emulations and other testing conditions. LLDP emulation and analysis provides one-button PoE LLDP protocol analysis and extends LLDP negotiated power-ups into PSE Conformance Test Suite and the PSE Multiport Suite. PowerSync Analyzer automation features all utilize pop-up Excel reports with colorful test limit outcome and statistical analyses. The PSL 3000 PowerSync Programmable Load is a low per test port cost PSE test instrument aimed at multi-port QA and final test applications. Like the PSA 3000, it offers static loading in excess of 42 watts per port continuously coupled with smart fan control. Programmable Load offers accurate DC metering for average DC voltage, DC current, and DC power with 2 aperture settings. The PSL 3000 supports a pure subset of PSA 3000 commands so that PSL 3000 automation scripts will run with either platform. The PSL 3000 also includes intuitive GUI software for interactive operation. The PSL 3000 is packaged in one of 2 configurations: a chassis accommodating up to 12 test blades with 2 test ports per test blade, or a fixed 24-port PSL 3024 instrument offering the lowest per port cost in the PowerSync analyzer family. The programmable load may be optioned with both the PSE Multiport Suite and LLDP emulation and analysis as described earlier. The PSL 3000 is a very cost-effective solution for live PD emulation used by PSE system testers to interactively assess administrative and power management decisions in PSEs ranging from 8 to 192 ports. The PSE Conformance Test Suite for the PSA 3000 turns the complex task of PSE specification compliance testing into a single button press that scans 1 to 24 PSE ports for 802.3 AT conformance. The suite boasts greater than 95% IEEE 802.3 AT PSE PICS coverage generated by 23 distinct tests that produce over 70 IEEE compliance parameters per PSE port. The test suite runs with both Type 1 PD Class 0 through 3 and Type 2 PD Class 4 emulations in order to fully assess PSE conformance given both 15.4 watt and 30 watt PD emulations. For LLDP-capable PSEs, testing with both Type 1 and Type 2 PD emulation includes LLDP analysis and emulation. One of the largest challenges to PSE test automation is a wide variety of PSE behaviors allowed under the 802.3 AT specification. The PSE Conformance Test Suite has evolved over 12 years to automatically adapt to a wide range of PSE pre- and post-power-up behaviors as required to assess specification parameters. Sifos works closely with all the prominent PSE silicon producers to assure that the PSE Conformance Suite properly adapts to the latest technologies. The PSE Conformance Test Suite includes power diagnostic capabilities such as on-the-fly waveform trace display, diagnostic output modes, intermittent result capture, and test deviation files. Many conformance measurements can be viewed as they are made or as they are evaluated. Automatically sequenced PSE conformance tests conclude in a colorful pop-up Microsoft Excel spreadsheet report encompassing 1 to 24 test ports per page. All compliance failures are clearly enunciated and statistics compiled across multiple ports. Users can flexibly select tests and ports to sequence, and the standard report will automatically adapt. The PSE Conformance Test Suite is supported feature option to the PSA 3000, PSA Compact, and PSA RackPack instruments. The PSE Multiport Suite represents an extremely unique and powerful set of capabilities for complex PSE system behavior testing and analysis. The PSE Multiport Suite consists of two components, Live PD emulation and the PSE Multiport Test Suite. Multiport Live PD emulation is based on a facility that enables 1 to 192 test ports to behave identically to a user-described PD. PDs may be modeled for classification, static load power, LLDP traits, pre-negotiated power, and line loss power. Both Type 1 or 13 watt and Type 2 or 25.5 watt PDs may be emulated. System developers can test PSE administrative features such as enabling and disable PoE service, total power consumption reporting, and other administrative reporting functions given a wide range of PD models. Racks of PDs traditionally used in system testing become obsolete. The Multiport Test Suite is a one-of-a-kind, fully automated test suite that evaluates PSE multiport power administration, power management, power stability, and multiport event timing behaviors of a PSE. The suite internally leverages live PD emulation to implement banks of virtual Type 1 and/or Type 2 PDs, including, where applicable, PoE LLDP emulations. Characteristics such as total PSE power capacity, transient power reserve capacity, and PD powering uncertainties are automatically revealed and presented in both tabular and graphical formats. Testing may be configured for PSEs with up to 192 ports. Like the PSE Conformance Test Suite, the PSE Multiport Test Suite automatically routes test results and associated statistics into a colorful pop-up Microsoft Excel spreadsheet. Both the PowerSync Analyzer and the lower-cost PowerSync Programmable Load are furnished with source code test scripts that may be utilized as is or modified by end users to rapidly characterize groups of PSE ports. These test scripts, PSA Quick Test and PSL Quick Test respectively, enable critical parameter testing of PSE ports in as little as 12 seconds per PSE port tested when tested in groups of 4 to 8 ports at a time. The scripts are accessed and executed from PowerSync Analyzer's PowerShell PSA programming shell. The PowerSync Analyzer family may be configured to evaluate PSEs that power all 4 wire pairs using non-standard proprietary techniques. These include manufacturer-specific formats such as POH, UPOE, and POE++. In the 4-pair configuration, a PSA 3000 or PSL 3000 test port can load at least 95 watts on a continuous basis with the ability to split power between powered pair sets in either a balanced or unbalanced fashions. Manual measurements and emulated power-ups are readily available from both the PSA Interactive Graphical User Interface and from PowerShell PSA, the command shell. Standardized waveform captures offer one-button analysis of 4-pair powering events and PSE signaling characteristics. The PDA 602A is an all-inclusive instrument that enables comprehensive qualification of 802.3 AT powered devices to assure interoperation with compliant PSEs in all possible connection environments. In one instrument, both powering and LLDP features of a powered device can be evaluated. The PDA 602A can be price-performance scaled. The base instrument is geared for manual measurements and user-automated testing of Type 1 or 13-watt PDs. With a license key upgrade, the PDA 602A can be configured for manual measurements and user automation for Type 2 or 25.5-watt PDs. The PDA 602A can separately be provisioned to run a comprehensive, fully automated PD Conformance test suite covering Type 1 PDs and, optionally, Type 2 PDs and LLDP-capable PDs. Finally, the PDA 602A can be licensed to emulate LLDP-capable PSEs and perform comprehensive PoE LLDP protocol analysis with Type 2 PDs. The PDA 602A is provided with a PDA interactive graphical user interface and with PowerShell PDA for rapid script automation. The PDA 602A offers robust and accurate metering that significantly exceeds capabilities in earlier generation PD analyzers from Sifos. Both load current and PD voltage are sensed in the physical interface with higher sampling and timing resolution. Waveforms of voltage, current, and power events are easily collected and presented in colorful Excel pop-up reports. The latest PD Conformance test suite offers more parameters and higher coverage exceeding 85% of 802.3 PICs for powered devices. This one-button test suite configures to test either Type 1 and or Type 2 PDs, including LLDP features if provisioned. With the Conformance test suite, the PDA 602A offers a powerful new load monitor offering real-time analysis and capture of PD power consumption and any violations of peak power, class power, power transient durations, and minimum maintained power. The PDA 602A flexibly emulates an LLDP-capable Type 2 PSE, allowing simultaneous communication with the PD while also serving and analyzing PoE LLDP protocols in power negotiations. PDs can readily be monitored to LLDP negotiated power levels in real time over long periods of time. The PDA 602A is connected to a host PC over a USB interface and is provided with a DLL format programming library to enable automation in programming environments beyond PowerShell PDA scripting. The PSA 3202 and PSL 3202 are second-generation PSA 3000 test blades for evaluating PSEs using PowerSync analyzers and PowerSync programmable loads, respectively. The PSA 3202 enables 4-pair PSE testing from either test port 1 or test port 2 on each blade. It includes resources such as single versus dual signature, multi-event classification, and auto classification that are associated with the future 802.3 BT specification. Unlike its predecessor, the PSA 3102, the PSA 3202 can load at least 95 watts continuously per test blade and supports LLDP using 10100 base T interface. Future 802.3 BT PSE conformance testing can be sequenced across up to 24 ports in a PSA 3000 chassis, while up to 12 ports can be simultaneously drawing 4-pair power at 95 watts. The PSA 3202 and PSL 3202 are plug replaceable with PSA 3102 and PSL 3102 test blades respectively. Existing software including 802.3 AT test suites such as the PSE Conformance test and the PSE Multiport test will run interchangeably with the newer blades. The PSA 3202 test blade will also be available in PSA compact form. Before introducing the 5U analyzer for twisted pair Ethernet physical layer test, let's take a look at some traditions and patterns that have emerged in the testing of 10100 1000 base T physical layer interfaces. We'll start with IEEE 802.3 specifications and test methods. 802.3 specifications tend to concentrate on transmitter testing with varying degrees of specificity across the different specifications. Receiver testing is at best vaguely specified. The tests defined can be challenging to carry out, especially if higher accuracy is desired. Detailed knowledge of specifications and of the metrology challenges not addressed by these specifications is required. IEEE specified testing often involves numerous time domain measurements requiring wide bandwidth digital scopes and specialized probing interfaces, and is therefore inherently hard to automate. The state of the art for these measurements is semi-automated testing of one transmitter pair at a time. Finally, many of the 802.3 specified tests for 1000 base T require silicon register access to activate test modes. Finished products with gigabit Ethernet do not offer these types of controls and thus cannot be tested using 802.3 specified methods. Largely because of these challenges, IEEE 802.3 physical layer testing has evolved into a silicon vendor service whereby testing is performed on reference designs and customer prototypes under arrangements between manufacturers and PHY silicon suppliers. Separately, independent test laboratories such as UNH-IOL have evolved into offering test services for a fee to both silicon vendors and manufacturers. Even here, 1000 base T testing can only be performed on prototypes and reference designs where access directly into PHY silicon is provided. Clearly, this type of testing tends to be once-only testing or very low sample rate testing. A third tradition we see in 10-100-1000 base T testing is the proposition that packet flow testing is a form of physical layer testing. While convenient to configure and execute relative to 802.3 specified testing, packet flow testing is functional testing, not parametric testing. When packets are dropped on a link, there is no visibility as to why packets are lost. The transmitter, cable connection, and receiver comprise a black box that either passes all packets or drops one or more packets. Packet flow testing typically requires a two-port device under test, such as a switch or hub, and ideally one of those ports would be known good. Packet flow testing is vulnerable to 1000 base T forward error correction and to retransmission protocols if carried out with TCP/IP. As with PoE test solutions discussed earlier, 10-100-1000 base T testing solutions from Sifos Technologies can be arranged on both product lifecycle and test process dimensions. The PVA 3002, or compact PVA, is a popular form factor for design evaluation and initial compliance testing. The instrument offers 2 test ports for evaluating Ethernet ports. PVA 3000 consists of between 1 and 12 PVA 3102 test blades, each with 2 test ports. This represents configurations from 2 to 24 test ports. Such configurations would be appropriate for testing multi-port systems such as Ethernet switches and routers. The PHY Performance Test Suite is a fully automated design validation or QA test sequence that evaluates transmitter performance, receiver performance, interface characteristics, and auto-negotiation functionality in 10-100-1000 base T ports. The suite can sequence from 1 to 24 ports to a single multi-page spreadsheet report with both tabular and graphical representations of performance, including per-pair transmitter characteristics. PSE-DC unbalance analysis is a special feature of the PHY Performance Test Suite, of particular interest to PSE designers during component selection and design verification. On the other extreme, the PHY View Analyzer is provided with a multi-port automated test program to assess certain critical parameters of 10-100-1000 base T ports in rapid succession. PVA Verify would be applicable when the need is to rapidly assess 2 or more ports, with optimal test times occurring as 4 to 6 ports are tested simultaneously. Let's now summarize the critical features of the Sifos PVA 3000 PHY View Analyzer. The PHY View Analyzer makes multi-port 10-100-1000 parametric testing available and productive to anyone, anywhere, anytime. Ethernet PHY testing is fully automated with direct instrument to device under test connection. There is no need of high-speed scopes, fixtures, differential probes, signal generators, silicon test modes, or cable spools. The PVA 3000 exposes and identifies 10-100-1000 interface defects that are hidden to and/or undiagnosed by ordinary packet flow testing, thus making it a cost-effective alternative to packet flow testing. The PHY View Analyzer resolves marginal Ethernet ports in pairs effortlessly and can serve as a time-efficient pre-screen for comprehensive 802.3 compliance testing. Coupled with the PHY Performance Test Suite, comprehensive transmitter, interface, receiver, and auto-negotiation analysis can be performed on up to 24 ports, that's 96 gigabit Ethernet pairs with a single button press. The PVA 3000 tests anything LAN. It will test any 10-100 1000 base T interface and can be used to test Ethernet cables, service outlet quality, link components, and even power over Ethernet effects on signal integrity. The 5U Analyzer's highly unique testing capabilities can be organized into two areas, metrology and receiver testing. 5U Analyzer metrology consists of three measurement categories: link assessment, transmission measurements, and interface measurements. Link configuration and link assessment involves metering of auto-negotiation parameters and link stability across a variety of forced auto-negotiation configurations. Precise auto-negotiation timing measurements expose potential problems in the auto-negotiation process. Link assessment is generally performed as a prerequisite to other PHY tests in the PHY Performance Test Suite. The 5U Analyzer provides four measurements of interest in transmitter testing. Power spectral distortion, or PSD, is a measure of transmission spectra deviation from a perfectly nominal frequency spectra. SNR is a measure of residual uncorrectable distortion in a transmitted signal. Wideband transmit power level is a measurement of total spectral power. Pair timing skew is a 1000 base T measurement of time or phase skew between transmit pairs. Interface measurements offered by the 5U Analyzer include wideband return loss and wideband crosstalk. Wideband return loss characterizes an Ethernet interface's impedance match on a per-pair basis, while wideband crosstalk summarizes power leakage between pair groups within a gigabit Ethernet interface. The 5U Analyzer makes a significant contribution to efficient and comprehensive receiver testing by offering a suite of precisely controlled impairments that can be applied while conducting either link stability measurements or packet flow measurements. These impairments include IEEE 802.3 worst case insertion loss, programmable alien crosstalk ingress noise, programmable timing offset, programmable timing jitter, adjustable slew, and a fixed impedance mismatch. Impairments make parametric receiver analysis both feasible and productive. The 5U Analyzer impairments can be combined and can be selectively applied to 10-100 base T receiver pairs. Link stability metering can be used as an effective substitute to packet flow testing, especially in 1000 base T, where the link stability meter takes advantage of the 1000 base T remote RX physical layer protocol. This method can be applied to any standalone Ethernet port. The 5U Analyzer also provides an elemental Layer 2 packet generator and counter for packet flow testing of receivers given applied physical impairments. This resource is useful when testing multi-port devices that bridge packets between ports, especially at the 10 and 100 base T link rates. The 5U Analyzer's PHY Performance Test Suite is, by far, the most automated 10-100 1000 physical layer test available anywhere. The test suite includes 6 automated tests covering transmission, interface, and receiver performance attributes. When sequenced, the PHY Performance Suite automatically adapts to device under test capabilities that in turn govern the testing that can be performed. PHY Performance tests can be sequenced automatically across up to 24 test ports with user selection of desired tests. With just a single mouse click, up to 96 gigabit Ethernet pairs can be fully analyzed. The PHY Performance Test Suite produces a colorful and graphical pop-up Microsoft Excel spreadsheet report upon sequence completion. The report, formatted as one page per port tested, includes colorful annotations and graphs indicating excellent marginal or problem performance. Also included in the standard report are estimations of certain critical 802.3 parameters, such as peak-to-peak voltage, rise-fall time, pulse mask fit, and droop. For PoE switch manufacturers, the PHY Performance Test Suite also includes a highly unique and fully automated test application to assess DC unbalance tolerance of PSE ports. This one-of-a-kind capability can be used to assure that PSE port Ethernet performance will stand up to any realistic worst-case unbalancing of DC current flow to a powered device. Sifos provides an automated test script that can be accessed and run from the PowerShell PSA console. PVA Verify offers rapid screening of 10100, 1000 base T ports on multi-port devices or on multiple devices simultaneously. Whereas a single test cycle of the more comprehensive 5-performance test suite may take over 20 minutes to complete, PVA Verify resolves key defects in as few as 75 seconds per 10100, 1000 port and 30 seconds per 10100 port. The test program evaluates transmitter, interface, and receiver performance characteristics including SNR, peak-to-peak voltages, low-frequency power, wideband return loss, and link stability both unimpaired and with IEEE 802.3 limit line physical impairments such as maximum link insertion loss. The software produces a tabular text formatted report that may be used for further processing. The report indicates good, marginal, or fail indications based on all test parameters. Thank you for your attention to and interest in Sifos products and solutions. Details covering any of the products I have discussed today are readily available from our website, www.sifos.com, in the form of downloadable data sheets and additional demonstration videos. Feel free to contact Sifos directly or to contact a local distributor of Sifos products should you have further questions. Your local distributor for Sifos may be found on the Sifos website. Speaking for all of us at Sifos, we look forward to helping you simplify the task of product verification both today and well into the future.